We're going to add, subtract, multiply, and divide with scientific notation. So you're going to see plus signs, minus signs, subtraction, division. This lesson is the same thing as our lesson today. Please write down what problems we're doing for classwork. For classwork, you're doing 102 to 107. 102 to 107. That's your classwork. Your homework is 9 through 14, or 109 through 14. Sorry, 109 to 114. This is all section 8. All right. So you are skipping a few assignments on your classwork, and that's by design. This classwork is easy and hard at the same time. So once we give you the notes, it's going to become a problem-solving classwork. In other words, you are going to solve problems instead of just add or subtract, multiply, divide. Any questions about the homework or the classwork or what we're doing? Okay, here we go. All right, one important thing. Please write this down. One important thing. One of the main important things you need is to know that all answers must return back to scientific notation. All answers must return back to scientific notation. In other words, throughout the process of working these problems, you may not have scientific notation at the end. You might change the problem in the way it looks. You might have to put the decimal somewhere else. But at the final step, you got to put it back into scientific notation. Okay, put it back into scientific notation. If you do not put it back into scientific notation, you are wrong. It's like forgetting units at the end of a word problem. Feet, inches, miles, whatever. Okay? Back into scientific notation. All right? Let's move on. Adding and subtracting. So, these are lumped together because they are the same type of problem. In other words, if you can add, you can subtract. All right, here we go. Oh, not yet. All right, one important rule to remember or something to consider. Exponents must become the same first. So when you add and subtract scientific notation problems, your exponents must become identical. In other words, times 10 to the 4th and a times 10 to the 7th, not identical. You need to make it identical. All right. So here we go. Let's do a problem. Here we got 1.2 times 10 to the 5th plus 5.35 times 10 to the 6th. You will always start out with two scientific notation numbers. In other words, they will be in scientific notation. However, just because they are in scientific notation does not necessarily mean you will end up with scientific notation, which is why I gave you the one important thing. All right, so if the exponents need to become the same, obviously 10 to the 5th and 10 to the 6th, not the same. So you tell me, do you want to change 5 to 6 or 6 to 5? 5 to 6? Okay, so Andrew says 5 to 6. Here we go. So that means I'm going to take this 10 to the 5th power. I'm going to change it to times 10 to the 6th power. And here's where we messed up on our quiz, a few of us. As a result of changing 10 to the 5th to 10 to the 6th, you got to realize which direction you're moving in. You can't think in terms of positive and negative. That's the bad way to think. Think in terms of space, direction. So I'm going to erase this circle here. All right, I'm going to place a green dot where the decimal actually is. Right now, it's between the 1 and the 2. But the 10 to the 5th power means it's actually 5 spaces to the right. So my decimal's over here somewhere. And by over here somewhere, that just means it's to the right. So if 5 changes to 6, and this is where the decimal is going, that means my spaces from 5 spaces has increased to 6 spaces. Okay? 5 spaces increased to 6 spaces. So if my decimal's here, which way am I going to move to increase my space away from this decimal? Okay? Better. I'm going to move left. If I move left, I'm moving further away from that decimal. And that is what a change of 5 to 6 does. It increases the distance from here to here. So right now it's 5 units away, or 5 spaces. One more space will cause it to be 6 decimal places away. So it's 0.12 times 10 to the 6th. Now my scientific notation, even though this problem is no longer in scientific notation, I can now add them or subtract them. Problem says add, so we're going to add. Well, let's line up our decimals, right? First rule of adding decimals, you line them up. 5.35 times 10 to the 6th plus 0.12 times 10 to the 6th. Now, this second part right here, the 10 to the 6th, these are like variables now. You just leave them alone. Don't do anything with them. Don't change them. It's like a common denominator. Once they are common, you don't add the 5 and the 5 in the denominator and get 10. So my final answer will have a 10 to the 6th power in it. So that's the point here. Look, 10 to the 6th, 10 to the 6th remains 10 to the 6th. Now 5.35 plus 0.12, just add like we normally do. 5.47. And we're pretty much almost done. One final check. Is your final answer in scientific notation?
Yes.
Okay, so we're good to go. Our answer is done. We're complete. If it wasn't in scientific notation, change it. Okay? Any questions about this problem? All right, let's move on. Let's do a subtraction problem. So see if you can actually do this one without me guiding you. So try to go faster than me. I'll still explain it, but try it on your own and see if you end up where I end up. Okay? I'm going to use Andrew's technique. Change 5 to 6. Might as well. Right? Change 5 to 6. So we have 8.41 times 10 to the 5th minus 7.9 times 10 to the 6th. This is not distributive property, ladies and gentlemen. Okay, we're not going to take this minus sign and multiply it in. The parentheses are just separating my numbers. Okay, so we're going to change 5 to 6. That means times 10 to the 6th power. Remember, this positive 5 means the decimal's over here somewhere. Okay, so I'm increasing my spaces from 5 to 6 spaces away from this decimal, so I'm moving left. So that's going to be 0.841. Minus 7.9 times 10 to the 6th. Now, here is the one thing about subtraction we need to get right. Okay, let's talk about adding and subtracting decimals. I'm going to ask you which one is correct. Okay, here we have two problems. Which one is written correctly? There's only one of them that's correct. When we're specifically using decimals to add and subtract, whether you have negatives or positives, there's a specific way to add them and a specific way to subtract them. Which one is right, which one is wrong? Okay? And why? Anthony.
The second one is correct.
The second one is correct. Why is the second one correct? Even though this one is just a reversed version of the second one.
Because with that one, you'll end up with a negative decimal if you...
Wait, first or second?
First one.
You'll end up, I'm going to end up with a negative decimal here too? Michael?
Because 7.9 is bigger than 0.84.
7.9 is bigger than 0.8. When you are lining up decimals and adding and subtracting them, especially subtraction, you need to make sure the larger decimal, I'm talking larger in terms of the value. 7 is larger than 0, right? 7 is larger than 0. Since 7 is larger than 0, you line it up with the bigger number of value on top, the smaller on the bottom. So this one on the left is absolutely wrong. Okay. So now let's add some placeholder zeros because we're going to need to borrow, right? So some of us still need that. So here we go. Just subtract like normal. So 10 minus 1 is 9. We're going to borrow 10, 9. 9 minus 4 is 5. We borrowed the 9. We borrow from the 9 to make an 8. 0. Negative 7.059. Okay? You are going to end up with negatives, especially when you subtract, because subtraction leads to negatives, right? What's our back end of this? Times what? There we go. Is this scientific notation? All right, so we're good. We don't need to change anything. Any questions about what I'm trying to drive home today for addition and subtraction? Okay. If you mess up here, moving the decimal, obviously your answer is going to be wrong, so be careful. Okay, be careful. Moving on, multiplying and dividing. Here we go. There's one thing you need to remember for multiplying and dividing, and that is not exponents. It's about how to use them. Okay, so you don't have to make them the same. You do not have to have them both be 10 to the 5th, 10 to the 5th, or 10 to the negative 3rd, 10 to negative 3rd. You just have to use your exponent rules. So multiplying and dividing, just think back to what we learned this unit. How do I multiply bases with exponents? How do I divide bases with exponents? Here's our third problem. 4.3 times 10 to the 8th times 5.2. Forgot a multiplication sign here. Let me fill it in. 5.2 times 10 to the 6th. There we go. All right. So with this problem, here's what you need to do. We're going to group our numbers together in terms of types. I see a decimal and a decimal. So I'm going to multiply those numbers together. This is going to be 4.3 times 5.2. Don't actually multiply it yet. Let's just organize it. Then the second type of numbers I have are my exponents, 10 to the 8th, 10 to the 6th. So now I have a separate problem, 10 to the 8th times 10 to the 6th. Do you see what I'm doing here? Okay, I'm creating two different problems because I have two different types of numbers. I can't start multiplying numbers that aren't the same kind, right? So let's do this one on the right. This is easy. 10 to the 8th times 10 to the 6th. What does that make? 10 to the 14th. Okay. Times, right? That we're just going to bring down the scientific multiplication part. We have to do 4.3 times 5.2. So here's where you take your calculator out. I'm going to let you use calculators on the test. And you're just going to multiply 4.3 times 5.2. Again, I don't really care about the steps here, so long as you understand you need to multiply them. So you're going to get a 22.36. All right, question. Is this a scientific notation answer? No, so let's change it. We're going to have to change this to be 2.236 times 10 to the something. Okay? So we know it moved one decimal space, right? It was between the 2 and 3, now it's between the 2 and the 2. So a movement of one space is going to change this by one number. Either it's going to be a 5 or a 3. So let's figure this out. In this problem right here, 4 means that the decimal is actually 4 spaces to the right, somewhere here. I'm sorry, 14. Thank you. Nearly messed up that problem. 14 means it's 14 spaces to the right. Now, I'm not going to actually count 14 spaces, but this decimal tells me that from here to here, 14 spaces in my head. Okay? I moved it left one space, right? That's where this is. So from here, I moved it left one. So what does that change to? 15. There you go. So to the 15th power. And that is your correct answer. And here's what I'm going to see on your test. Some of you are going to tell me 13 because you do 14 minus 1 and you gave me 13. So you got to stop thinking in terms of just left and right, positive, negative. Think in terms of direction. Which way am I going? Am I moving away from my decimal or toward my decimal? Yeah.
So in a problem like this, would you want us to solve 10 to the 15th power?
No, because we want scientific notation. So you would not multiply that out. Any questions so far? Last problem, number 4. This is a division problem, and to me, these are actually the easiest. They are almost like too easy. So, 7.8 times 10 to the 3rd, 0.2 times 10 to the 5th. Remember, multiplying and dividing are the same type of problem, so we're going to group them. We're going to group them. We're going to group the decimals together, and then we're going to group the exponents together. Exponents are the easiest to work with. So, remember, scientific notation means 1 point something something or decimal point something something times 10 to the power. That power can be negative or positive. So let's review real quick. Let's say I had this problem. Don't write this down. Right? Simplify it for me. What do we get? All right. Now, the shortcut would be I take 5 and I 3 and I subtract. So it's really 10 to the 5 minus 3, which makes sense? Okay? But if I look at this problem, it's the opposite order. So 10 to the 3rd is on top, 10 to the 5th is on bottom. If I follow the same pattern as this, using subtraction, what do I end up with? Negative 2. So that's what we're going to do. That exponent part is going to be 10 to the negative 2. Because we want to keep things in one line. In scientific notation, we don't want to see fractions. Okay, we don't. That's why we keep it 10 to the negative 2nd power. Now, 7.8 divided by 0.2. All right, so 7.8 divided by 0.2, what do we get? 39. Is this scientific notation? Nope, it's not, so we have to change it. It's going to be 3.9 times, obviously, 10 to the something. Okay, so let's think. Again, if you don't know where the decimal is on 39, it's at the end right here. It's right after the 9. So negative 2 means that it's actually supposed to be 2 units to the left. It's actually supposed to be over here. So I went and took those 2 spaces, and now I moved closer by 1. What does that negative 2 change to? Negative 1. It's a negative 1. Some of you are like, Mr. Kim, isn't it supposed to go the other way, get smaller? You're thinking in terms of integers. Integers, yes, negative 3, negative 4 is smaller. These negatives here represent spaces. Spaces to the left or spaces to the right. This means 2 spaces to the left. Now it's 3.9, so I only move 1 space to the left, or negative 1st power. Yeah.
Why is it that you can subtract
the exponents, but you can't subtract like, the decimals.
You can't subtract
To
the,
divide.
you can't subtract the decimals because decimals are not in exponent pound. They're not written as exponents. So they're actual numbers you can add, subtract, multiply, divide. Okay. Any other questions? Okay. So here's what I want you to do today. Go ahead and open up your iPads to today's lesson. What you're going to need to do first is this. You have 6 problems to do. The majority of them are word problems. In other words, you're given a situation and you have to attempt either multiplying, dividing, adding, or subtracting. What I'd like you to do with your table right now is go through each question without answering it and decide what you should do. Should we add? Should we subtract? Should we multiply? Should we divide? Do that now for all 6 problems.